Hey guys, it's David White for EMS training. This is a PowerPoint I've been wanting to do for a while. I've had a lot of people ask me how to understand the whole metabolic respiratory acid base. It gets very confusing. A lot of people don't explain it very well. So what I'm going to do here on this one is we're going to keep it very, very simple. Keep it pretty short, probably 15, less than 20 minutes maybe. So let's go ahead and just jump right in. So when we're talking about our acid base, we have to look at the pH scale. So 7 is neutral, and 0 to 6 is going to be your acidic state, low numbers. 8 on up to 14 is going to be your alkaline, alkalosis, or your base side. We live right about here in our homeostasis, 7.35 to 7.45. We're going to get into that just here in a few minutes. All right, so what are these acids and bases? What does this stuff mean? This whole thing is just a measurement. That's all it is. It's just a measurement of hydrogen ions, and then we call this our pH. That's it. All right. The pH is measured using what's called a negative logarithmic scale. Now, I know that sounds scary. Look, you see this chart here. It's kind of overwhelming. Don't sweat it. I'm just showing this to you so you can understand that we live here, 7.35 to 7.45. If we were to go to 6, that is not just one jump. These are exponential of times 10 from one to the next. So let's just say, for example, you were here at 4, you had 4 cookies, and you went to 5, you didn't get 1 additional cookies, it went times 10. So these are really, really big jumps. We can only stay in a very, very narrow window. If we get outside of here, then we are close to death, okay? Or seriously bad things are happening. So that's all I wanted to show you on that. I just want to keep that real simple. Don't get hung up on this. That just means the numbers jump times 10 for each one. All right, so your body is constantly in this state of flux, trying to keep you in homeostasis. The whole body has 3 major buffer systems, but luckily for us in the EMS world, we're only going to have to worry about bicarbonate. The rest of this, you're not going to see on registry. You're probably not going to see it in your books. Don't sweat it. All right, so this production and breakdown of carbonic acid, which I'm not going to get into a whole lot, this whole thing is just called your buffer system. So what this means is if your body's pH level is too low, which means your acidity levels are too high, your body is going to absorb hydrogen ions into the buffer system to restore the balance. And then it's the opposite. If your pH level becomes too high, it's going to release hydrogen ions to get you back into homeostasis again. All right, this whole buffer system, it works in 2 parts, the renal system and the respiratory system. So talking about the respiratory system first, if you kind of want to get a little into it, your carbon dioxide is created by cells. It's completely natural. It's just a byproduct. It'll combine with water. This forms the carbonic acid. Then it gets separated into hydrogen ions and bicarb. So these hydrogen ions, they catch a ride on hemoglobin, which is on your red blood cells, takes a ride back up to the respiratory, to your lungs, and the carbon dioxide is released from the lungs during exhalation. This whole thing is just called the respiratory system control of the whole acid balance. All right, so if your carbon dioxide levels are too high, the brain's going to trigger the respiratory system to increase both the rate and the depth to help get rid of some of the carbon dioxide. And in this, the opposite, if the carbon dioxide levels are too low, it's going to slow down everything. Compared to the buffer system, the respiratory is very quick. It's effective to a certain extent. It's only about 75% effective on your acid-base imbalance. It's really important, but you have to remember it's the quick fix to your body's system. and that's compared to the renal system. The renal system is much more efficient and much more effective, but the problem is it takes much longer. It takes days, some days to work. So we may or may not be able to recognize this portion of it in the field. All right, so if you put this whole thing as a whole, the body's going to trigger the respiratory system as a quick fix while the renal system starts, but it's going to take much longer for this. But once it does work, it's going to be much more effective at controlling our pH balance. All right, so this breaks up into a respiratory acidosis and respiratory alkalosis. Acidosis, this is the signs for this going to be headaches, anxiety, restlessness, and as they increase, your body, the patient's body may lose consciousness. So what are we going to do? We're going to restore adequate ventilation with a bag valve mask, maybe a CPAP. Medics can do intubation, and then of course we're going to look at some medications such as your bronchodilators. Respiratory alkalosis, on the other hand, it is where you have a lower than normal carbon dioxide. This is where you're going to get hyperventilation, and these people are going to be complaining of spasms and tingling and numbness in their hands and feet. It scares the crap out of them, and which makes it worse. They breathe faster. It gets worse and worse and worse. So our treatment here is focusing on whatever the underlying problem is. If it's a psychogenic hyperventilation, which is just simply an anxiety attack, you got to calm them down. All right, the other side of this is a metabolic acidosis and alkalosis. So a metabolic acidosis, nausea, vomiting, weakness, you can even get into comas, cardiac dysrhythmias. We've got to figure out what it is. We can take a blood sugar. If it's way too high, we can say they're in DKA, which is a metabolic acidosis sign. Hyperkalemia, where there's too much potassium in the body. Poor renal function because their buffer system's not working. Overdoses like your tricyclics. These are all pretty significant things that we're going to have to fix. For the medics, bicarb is going to be administered, which is a supplement to what the body's bicarbonate. Right, metabolic acidosis, they're going to be muscle spasms, chest pains, seizures. It's a little more rare compared to the other ones, but one of the big causes here is massive vomiting and diarrhea. Once you lose large volumes of fluid, you're going to go alkalosis because that bicarb is in the bloodstream. So if you're losing blood, if you're losing fluids through diarrhea, you're going to have a patient in an alkalotic state. Our treatment for this is going to be an aggressive fluid resuscitation. All right, so we got 3 measurements we have to be concerned with when we're talking about acid base. Where do they come from? All right, in hospital, it's a ABG. You can see here in the picture, this is somebody's wrist, and they're going right into an artery. They're going to take a little blood sample, send it up to the lab. Obviously, we don't do this in the field. So your first of the 3 measurements we're going to look at is the pH. So your normal pH has to be between 7.35 and 7.45. Anything else, bad things happen to us. Carbon dioxide, normal range, we call this the PCO2. Normal range is 35 to 45. It's measured in torr. For the EMTs in advance, that's not super important. You probably should see it and just so you've heard of it before, but not super important. Medics maybe want to be a little more familiar with it, just for your testing purposes. This is something that we can measure in the field with capnography. This is our capnography numbers, 35 to 45. Above 45 will put us in an acidotic state. So remember, this is the same as capnography, so it's opposite of our respiratory rate. So if our respiratory rate is slow, we're retaining CO2, we will be above 45. If we are hyperventilating, we are going to blow off too much CO2, putting it at a level lower than 35, putting us in an alkalotic state. And then our third and final value we have to know is our bicarbonate, or what some people just call bicarb. Normal levels is 22 to 28. Below 22 is acidotic, above 28 is alkalotic. All right, so a real simple way of doing this, draw you a tic-tac-toe. We're going to label this over here as our acidosis side, our alkalosis side, and then normal in the middle. So we put our normal values in here, 735 to 745. We put 35 to 45 for our carbon dioxide. It's nice because these are the same numbers, so that helps us to remember it. And then our bicarb is 22 to 28. Now what I want you to pay attention to here is, as on the previous slide, below 35 is alkalosis, above 45 is acidosis. So a real easy thing to do, just flip-flop the numbers. That keeps everything acidotic lined up, everything alkalosis lined up. All right, so here's the steps I just kind of went through. Draw the tic-tac-toe, look at your pH. Is it above or below normal limits? Your carbon dioxide, check your bicarb levels, and then put your X's in the appropriate boxes. So, example here, you're given arterial blood gas values of a pH of 7.22. 7.22 is below 7.35, so we put our X over here in the acidotic side. Carbon dioxide level of 48 is above 45, so again we put it over here in the acidotic column. Bicarb level of 30, it is above 28, so we're going to put that over here in the alkalosis side. So now we have some answers here. Now what do we do with this? If the pH and the carbon dioxide are in the same column, it is a respiratory problem. You have to look and see, is it acidotic or alkalotic? If the pH and bicarb are in the same column, then it's metabolic. Then you just look at which column it's in. So this is the one we just went through. We have the 7.22, which is acidotic, carbon dioxide of 48. They're both in the same column, so that means it's respiratory. These are in the acidosis column, so this is going to be respiratory acidosis. How hard is that, huh? All right, another example here. pH of 7.49, that's above 4.5, so we put our X over here. Carbon dioxide of 42, which is normal, so we put it in the normal column. And a bicarb of 30, also over here in the above 28, so we put it in the alkalosis side. And since the pH and bicarb are in the same column, this is going to be a metabolic problem. It's in the alkalosis column. It is metabolic alkalosis. That is simple as it can get, guys, right there. All right, this method is going to answer about 80% of what you're going to be looking at. It does get a little deeper into it. When I originally wrote this PowerPoint, I was going to get much deeper into it, but I feel like that, let's just keep it simple. I think that's about as far as we're going to go there. I'm just going to mention this. The next step in this would be to see if they are fully compensating, partially compensating, or if they're completely uncompensated. So last slide here. Here's one to take note of. If it's fully compensated, the pH has to be normal. Has to be normal. If it's partially compensated, it will be all three values are going to be in an abnormal column. Nothing will fall into the normal section. And then if they're uncompensated, if your carbon dioxide or your bicarb is normal and the other is abnormal, then they're going to be uncompensated. So a little pearl here. If the pH is abnormal, it cannot be compensated. It has to be either uncompensated or just partially compensated. If we get anybody that goes and takes registry, if you did have any of these questions on there, please let me know. I will do a follow-up to this, and then we'll get into that a little deeper. I've not had anybody yet tell me any of this was on registry, so I'm going to leave this part out. I'll just leave this up. You can take notes if you want. And that's going to be it for this video. So if you like the video, let other people know, please. And if there's any other type of classes you want to go through, anything specific, leave a comment. shoot me a message, and then we'll see if we can get some clarification for you. All right, guys, thanks a lot. Pass the video around.